I'm Chaitanya. I'm the head of engineering here at Sirona, and the team and I work on the core platform.
Hi, I'm Jeff Queissser, co-founder at Box, and I'm a technology advisor to Sirona Medical.
Jeff, one of the things we hear a lot from radiologists that they're not sure how different cloud native is from legacy solutions. Can you help explain, please?
Yeah. So there's fundamentally two different architectural paradigms that are at play here. That you have on-prem software typically was developed 5, 10, 15 years ago, and then you have cloud native software. On-prem software is all focused around the idea that there will be one piece of software that is deployed and run on a customer's premises, which can mean it can be in a server closet or it can be in a data center. And it's really an N of one software architecture and software model where the software only has to be as sophisticated as, or as secure as, or as scalable as necessary to support an individual customer. And so that's an on-prem, like we would call that a legacy software architecture. If you contrast that with what's been happening for the last 10, 15 years, really the vast majority of the world and technology business have actually moved over to a cloud native architecture and a cloud native stack. And what that means is that you can actually you can take advantage of what is effectively a distributed supercomputer that exists at 50 locations around the world to run that piece of software. And actually that has very different downstream implications for the type of software that you built.
We hear a lot about security from our customers, our radiologists, and they wonder how cloud native software is more secure than the legacy software they're currently using.
Yeah, it's a great question. So it really all starts with how the software was designed from the very beginning. If you are building software that was maybe 10, 15 years ago, there's less internet, there's less sort of mobile workforce, and you've designed the software to run in a localized data center that is always going to be protected by your company or your hospital or your practice's firewall, you build the software in a very different way than if you decide from day one that we're going to architect the system to be highly scalable, run in the cloud, and accessible on any device. And so what that looks like is ends up for any piece of complicated software, you can typically imagine there will be millions of lines of code that were written through the lens of this will run in a server closet, and not necessarily with the full lens of this is going to actually be a fully internet deployed application. And so basically you've got millions of lines of codes that maybe haven't been audited or were not designed with security from day one. And so what happens is you end up with a bolt-on security approach, which is these vendors go back and of course they want to ensure that they've built as secure software as possible, but fundamentally, architecturally, that's still a bolt-on instead of we've designed the software from its core. So one would be when you build for cloud native, you have you built using an updated threat landscape and threat model. So you understand better what are the ways that security compromises are happening and how do we make sure we can plan from that from day one. And two is every line of code that's been written from jump actually is designed around this is our updated kind of threat model. The next piece of serious kind of tailwinds that you get on security is that if you're running in a cloud hosted facility, so for example, if you're using AWS as a cloud provider, you're actually taking advantage of literally hundreds of or billions of dollars of technology R&D and security R&D that have gone into actually securing that stack. And so those would be two major reasons why you'd find typically a better security posture in a cloud native piece of software versus something that was on-prem and originated 10, 15 years ago. And from personal experience back at Box, 10 years ago, there was really a legitimate question about how secure is the cloud and are we sure that it's more secure? But there's now been enough runtime where there's trillions of dollars of public market cap that's all running on this architecture. So I think it's a very logical and it's a super valid set of questions. And what I'd say is that very definitively, architecturally, the question has been answered, which is the cloud native security approach is actually a better model than the on-prem approach.
So obviously we build on top of Amazon and we get all these benefits that you described. And we add on top all the real-time tooling, monitoring, alerting capabilities so that our customers don't have to think about it at all.
Yep. And the other thing that's really nice about this cloud model instead of an on-prem model or a lift and shift, which is when you take a formerly on-prem application and host it in the cloud, is if there's any security patches that need to go out, as a customer, the customer doesn't have to do anything. The Sirona team will determine that and can actually have a hot fix or a security patch released in, under 2 minutes?
Yeah. It's a whole ecosystem that works together. Our vendors have security patches. We subscribe to security notifications. If anything comes out that we need to update, most of the time it just automatically happens as part of our regular updates. We don't even have to do much. But if something serious comes out, we can absolutely roll out patches as quickly as in a few minutes as needed. These updates are free, automatic, and available to all of our customers. Another thing that matters a lot to our radiologists is reliability. They want to be able to work when they want, how they want. How would you say cloud native applications are serving those needs better than legacy systems?
Yeah. Well, it's another very good question. So cloud infrastructure you can contrast with typical on-prem infrastructure because it tends to be built on what are called distributed systems, which means that there is redundancy built into the system. So imagine instead of having one database to run your application, and if that database is offline, planned or unplanned, or it's being upgraded, the whole application is offline. So that would be an on-prem or a lift and shift kind of model. If you take a cloud native model, the same database would actually be running virtually across multiple machines simultaneously. And so you have built-in fault tolerance. And so fundamentally, all of the low layers of infrastructure that are required for the application to function are going to be, by default, are going to be distributed and running with some fault tolerance. And so that right there already probably adds at least a 9 in the number of 9s that you get in reliability. So the way that this manifests and affects an actual radiologist at the end of the day is in a cloud native architecture, it's much more likely that the system, and this is true for Sirona, fundamentally there are no planned downtime windows because everything is designed to be available 24/7 and upgradable online, which means you never have to take the system down. If you contrast that with a 4-hour downtime window where there's going to be a system upgrade, that's incredibly disruptive to actual workflows. And this is healthcare. There's people's lives that are at stake, so you can't afford to be down.
Absolutely. That's really why at Sirona we have triple redundancy. Our software is deployed in multiple places around the country. And even if something happens, and Amazon systems are very reliable, they stay up, but sometimes they can go down. We can automatically switch over to a different data center, different databases, different processing systems.
And this you just fundamentally can't do with an on-prem piece of
Absolutely.
software. The other advantage that you get from this, just building on that same architecture of running across multiple data centers, is that the performance that the end user experiences can be much, much faster. Because if you run from one location and then you're visiting the opposite coast, you're going to experience typically very poor performance. If you can run an arbitrary number of data centers, it actually means that you can always have that data set located as closely as possible to the radiologist.
We also move the data as close to the user as possible using the latest technologies there. This is how we are able to tackle hard problems like speech-to-text accuracy, latency, and viewer load times, image load times that have plagued any other attempts to solve this in a cloud-native way before.
Right, and with this architecture, what you're actually seeing is it requires being within, call it 100, 200 thousandths of a second away over the internet from the end user in order to really drive the kind of performance that the end user expects. And you can only do that if you have 30 or 50 data centers or locations across the US or across the world.
Yeah, and that's really only possible with cloud-native deployments.
Another typical advantage is that the cloud-native stack has a much more modern and way higher productivity tool chain and tool set that's attached to it. Can you talk about how you guys have deployed some of that, and what are some of the benefits for customers?
Yeah, absolutely. We can't even imagine annual releases. The expectations are different now. Nobody wants to wait months after having asked for something, and we can deliver as fast as our customers want.
And so how do you guys make sure that you're both deploying incredibly quickly from a velocity perspective, but also ensuring that the quality of the software is at the highest possible level?
Yeah, we use the latest technology to make sure our software is safe, high quality. With the push of a button, we can run hundreds, thousands of automated tests, come back and see the results, and then make sure that the software is actually ready to be deployed.
So given the speed that you guys are able to build new features and improve the software at, how do you make sure that every morning that a radiologist wakes up and logs in, they're not walking in and loading a totally different product?
We make sure that our radiologists can choose to accept the features when they're ready. We can do targeted releases if necessary for only the people who want a certain functionality. We have a lot of control and it's instant.
Got it. So you guys are able to move very quickly on the development, but you ultimately hand the keys over to the customer to decide when they'd like to turn on those new features and make them available.
If they like. If they want us to take care of everything, we can do it for them. They don't have to lift a finger. Everything just magically works. But if they're conscious about when to adopt features, we can absolutely let them have control over it. We can do deployments once a week whenever we want, but we can also put things behind something that is known as a feature flag. And this is exactly how we are able to deploy not just individual features, the single click, but entire suites of AI technology to our customers incredibly fast.
And that's in line with an industry best practice to use feature flags. The other thing that I think would be good to talk about is how do you have this architecture in this regulated of an environment. And so one thing on my end is about 10 years ago, Box actually bought a DICOM viewing piece of software. And so I have some personal experience with the regulatory landscape here. I'm curious how at Sirona have you guys handled the ability to move quickly, to innovate, to deliver high quality, highly secure software, but also make sure you're doing that in the context of this regulated framework?
So we've built a team here with a variety of experiences. They've done this stuff before. They've built world-class population scale software that some of us use every day. We also have experts from the industry who are advising us, who are helping us, guiding us build the best-in-class software for healthcare, but leveraging modern applications, modern systems, modern tooling. Tax companies and reporting companies, maybe class one, which are much simpler than the standards that we are held to. We have whole quality management systems and processes to help us deliver software quickly, but yet safely.
And I'll just add that rigorous process is essential for building highly secure, highly available, and high quality software. And so what I've seen from my advising lens of the way you guys operate is that it's a compliance first culture, it's a security first culture, and you're completely focused on how you drive process that's going to enable you getting to those outcomes. So fundamentally, you're building in a way where the software is held to a higher bar, while you're also simultaneously building faster and higher quality.
Absolutely. So Jeff, if there was one thing that you would want our customers to know about the way we do things, what would that be?
Well, I'd say that this is a business that was built very, very thoughtfully from a technology perspective from day one. Of course, as we talked about, it enables higher security, higher reliability, and higher velocity. But fundamentally, this is very real and very proven technology. So we're now 15 plus years into the cloud transformation into cloud native technology. So your customers can take comfort knowing that fortunately, this is very well proven technology that moving to the cloud has an incredible range of benefits. And even if Sirona is the first in this marketplace to go do this, that this is completely and absolutely the right architecture to build on.